All right, so in 8.3, we're talking about geometric sequences and series. So when we multiply by the same number every time, we call that a common ratio. And we use the letter R for that. So we're going to tell whether each of these is geometric or not. So to get from 6 to 12, I would have to multiply by 2. But 12 times 2 is 24. So we're obviously not multiplying by the same thing every time. So this would be a no. On number 2, negative 3 times negative 8, or negative 3 times 6 is negative 18. Negative 18 times 6 is negative 108, times 6 is negative 648. So my common ratio would be 6, and this is geometric. Another good way to look at this is if you take a number and divide it by the number that's in front of it, it will give you your common ratio. So negative 18 divided by negative 3 is 6. If I were to do that with negative 108 and divide that by negative 18, that is also 6, so on and so forth. All right, so here's our rule for geometric sequence. It's very similar to arithmetic sequence. You still need your first term, but that 1 refers to the same one that's right here. So if I were to put the 5th term here, this would be a 5. So we're going to write the rule. We obviously need the common ratio and the first term. So the first term is 5, and every time I am multiplying by 3, so my common ratio is 3. So therefore my rule would be A7 is equal to the first term times the common ratio raised to the n minus, that's the first term, so 1. All right, and I'm not going to go through this process, but as in previous lessons, if we wanted to find the 8th term, we would just plug 8 in for the n right here. All right, so my first term on number 4 is 88, and my common ratio, I see that these are going down by a half, and they are alternating signs, so I am multiplying by negative 1/2. Again, you could take negative 44 and divide that by 88 to get you the negative 1/2. So my rule would be A7 is equal to first term times the ratio raised to the n minus, this is the first term, so 1. And again, if I wanted to find the 8th term, I would just plug 8 in for the n value. All right, so I am given the 4th term and the r. With geometric sequences series, we need the very first term. So I'm going to find the first term. And normally I would put the first term right here, but I don't have that, so I'm going to put the 4th term, which is 12, times my ratio raised to the, this is where the n normally is, so 1 minus, and this is where the first term normally is, but it's the 4th term, so minus 4. You can plug that directly into your calculator, and it will tell you that your first term is going to be 3/2. Then you have your r value of 2, and you're ready to write the equation. So a sub n is equal to first term times the ratio raised to the n minus, that's the first term, so 1. So we'll do the same thing here. I want to find the first term, so I'm plugging 1 in for n, and since I have the 5th term, I will plug that where I normally put my first term. So I have 32 times my ratio of 2/3 raised to the, since this represents the n, or the number I'm trying to find, 1 minus, and then this is the 5th term, so 5. So therefore my first term is 162, and then I have my ratio of 2/3. So A7 is equal to 162 times 2/3 to the n minus, that's the first term, so 1. So on number 7, I do not have the first term and I don't have the common ratio. So I'm going to use both of these to figure out the common ratio. So as always, I'm going to put the bigger termed number out here. So negative 68 is equal to, and then 12 times r, I don't know what that is, raised to the, this is the 5th term, this is the 2nd, so 5 minus 2. So I'm going to go ahead and divide by 12. So negative 768 divided by 12 gives me negative 64. And then this is r to the third. So to get rid of that cube, I'm going to cube root both sides. So r is negative 4. And then I need to find the first term. So I'm going to plug 1 in. Now I can use either of these. It does not matter which one. So I'm going to use the second term. So 12 times my common ratio raised to the, this is 1, minus, this is the second term, minus 2. So my first term is negative 3. And now I'm ready to write the equation. So a sub n is equal to negative 3 times common ratio of negative 4 raised to the n minus, that's the first term, so 1. All right, same thing here. I need to find r, so I'm going to use both of these. I'm going to plug the 3 out here since it's the fourth term, and the 12 in here since that's the second term, times r to the, this is 4 minus 2. So if I divide by 12, I get 1/4 is equal to r to the 4 minus 2 is 2. And then I will square root. Now there is something that you need to think about when you do this. I can tell right here that my ratio is going to be negative because this even term is positive, but the odd term is negative, which tells me that I'm multiplying by a negative because my signs are alternating. I can't tell on this one because they've given me both even terms. So I can't tell if it's alternating or not. If this was like a sub 5 and it was a positive, then I would realize they were not alternating. So I'm going to go with the positive version. So the square root of 1/4 is 1/2, and that represents my r value. And then I'm going to use one of these to come up with my first term. So a sub 1, I'm going to use this one right here, is equal to 12 times my ratio of 1/2 raised to the 1 minus 2 because that's the second. So my first term is 24. So I'm going to use that with my ratio to write my rule. So a sub n is equal to 24 times my ratio of 1/2 raised to the n minus, that's the first term, so 1. All right, when finding the sum, we have this equation. So we always need the first term and we need the ratio. So the first term, as long as this is minus 1 up here, then that tells me that this is my first term. If you're unsure, what you can do is plug 1 into the equation and you're going to get 4 anyways. All right, and then I also need my ratio, which is always the number that is in the parentheses that's being raised to the exponent. So my ratio is 3, and then my n value is how far I'm going, which would be 10. So the sum of the first 10 terms is equal to the first term times 1 minus r to the n, which is 10, over 1 minus r. Plug all of that in, and you're going to get 118,096. So over here, I can't say that this is the first term because this doesn't have that minus 1 behind the k. So to find the first term, I'm going to have to plug in a 1. All right, so I have 1/2 times 5 to the first, which is 5/2. My r value is the number that's being raised to that exponent, so 5. All right, and then I also need how far I'm going, so it's the first 6 terms. So the sum of the first 6 terms is equal to the first term times 1 minus the ratio raised to the n over 1 minus the ratio. So the sum of the first 6 terms is 9,765.